All right, so let's go ahead and talk about solutions, but specifically how we measure the concentration of a solution. So the concentration is considered the amount of solute per volume of solution. So, if I said, for example, during passing period, there's a high concentration of students in the hallways, that means there's a lot of students per area or volume. And so concentration is just the amount of stuff you put in the solution versus the volume of the solution. So you can either be dilute or concentrated. So concentrated means there's a high amount of solute per volume of solution. Dilute means there's not much. So molarity can be broken down into moles of solute over liters of the solution. So it's a mole per volume. And so, for example, if I have 2 molar solution, that means that this is 2 mole. It's a molarity of 2. But what does a molarity of 2 mean? Well, it just means that there's 2 moles per 1 liter. So if I have 1 liter of a solvent, or of solution, I should say, and let's say each of these represents a mole, I have 2 moles per 1 liter. So let's say each circle represents a mole. So I can use that ratio to figure out if I have 2 liters and I have the same concentration, that means I would have 4 moles, right? Or if I had half a liter, that would mean I would have only 1 mole, right? As long as it's a 2 mole to 1 liter ratio, that's what a concentration is. It's really just a ratio. So let's go and solve some problems together. So what would be the molarity if 3.5 moles of sodium chloride were added to 3.0 liters? So remember, molarity is equal to moles per liter. So I know I have 3.5 moles over 3.0 liters. So my final answer should be 1.2 molar. So I'm figuring out molarity. The unit of molarity is that big M, or molarity. And so big M is the abbreviation. 1.2, I think it's like 1.1666 repeating. But I only have 2 sig figs. So 2 sig figs is the smallest number of sig figs I started with. So 1.2 has 2 sig figs. Next problem says, how many moles would be necessary to create a 2.0 molar solution in 200 milliliters? So molarity equals the moles or the liters. So a couple things to note here. I'm starting with molarity, so I have 2.0 molar. And we want to figure out moles. I'm going to make moles X, and then I want to figure out the liters. However, I'm given 200 milliliters, so I have to actually convert this. I know that there's 1,000 milliliters in 1 liter, and so this would be 0.2 liters. Put this here. Now I've converted liters, I can plug it into my equation. The way I'm going to teach this, there's many ways of doing this. There's an algebraic way to solve it, but anytime I have x in a fraction, I'll just cross multiply. So I know 2.0 is also 2.0 over 1. If I cross multiply, on one side I have 2.0 times 0.2, and then x times 1 is just x, right? So x will equal, and it's going to be in moles because it's asking how many moles. This would be 0.4 moles. What volume should I use to create a 0.5 molar solution if I have 3 moles of salt? So my molarity equals moles over liter. I'm trying to figure out volume, so I'm going to actually figure out this one. My molarity is 0.5 molar equals 3 moles of salt over X. I know that 0.5 mole is just over 1, right? So I have 3 on one side equals 0.5x. Divide both sides by 0.5. And X equals 6 liters. And that makes sense. So if I have 3 moles over 6 liters, my molarity will be 0.5 mole, right? 3 divided by 6 is 0.5. 1 sig fig, 3, and 0.5 have also only 1 sig fig. The last problem, molarity equals moles over liters. So here I have 35 grams of NaCl and then 500 milliliters. So 35.0 grams has to be converted to moles. I use the molar mass of sodium chloride. So if you get this, it's 0.599 moles of NaCl. So now I've converted it to, I'm going to do it over here, so 0.599 moles. And then I'm given milliliters, so milliliters I need to convert to liters. So you want to make sure it's always going to be moles over liters, right? So here I have to convert my milliliters into liters, and then I can plug it in. So if you get this now, 500 milliliters has only 1 sig fig, so my answer should have only 1 sig fig. Divide the two, you get like 1.19 something, right? So it should be just 1 molar of NaCl. All right, there's more practice here along with the answers.